Hello everyone, welcome to the next tutorial. In this tutorial, we are going to learn about inductor combinations. Okay, so when the inductors are connected in your series and your parallel, so what will be the equivalent inductance? Okay, so let's say in the first case, we have a series connection. When the inductors are connected in series, let's say this is your L1 inductor, this is your L2 inductor, and it is connected between a DC supply of voltage V, and I is the current flowing from these particular inductors. Okay, so let's say the voltage drop at L1 is your V1 and the voltage drop across L2 is your V2. Okay, so according to KBL, we can say that according to KVL, Kirchhoff's voltage law, we can say that V will be equal to V1 plus V2. Okay, so we know that the equation of EMF or the Ohm's law in case of inductor is E is equal to L d by dt of your I. It means that on simplifying it, we can say that V will be equal to I. So L, equivalent inductance L into di by dt. Okay, I is the current flowing from this particular these particular two resistors. Okay, is equal to V1, or you can say E1, which is equal to L1 di by dt plus L2 di by dt. It means that, so L equivalent di upon dt is equal to di by dt L1 into L1 plus L2. Okay, so the total inductance for two inductors will be L equivalent is equal to L1 plus L2. Okay, so for n inductor combination, so for combination of for n inductors connected in your series, the total inductance will be equal to, so total inductance will be L equivalent is equal to L1 plus L2 plus so on plus Ln. Okay, I hope it is clear how we are getting to this particular expression. Okay, so in the next case, in the second case, when the two inductors are connected in your parallel. Okay, so let's say this is your inductor L1 and this is L2, and they are connected across a DC supply of V volts. And since like these two inductors are connected in parallel with the voltage source, so the voltage across here will be your V. Okay, let's say this is the current I which is flowing, and this is the current I1 flowing through the inductor L1, and this is the current I2 flowing through the inductor L2. Okay, so according to KCL, we can say that I is equal to I1 plus I2. So differentiating current with respect to time, we are getting di by dt will be equal to di1 upon dt plus di2 upon dt. Okay, so we know that E, or you can say V, is equal to L d upon dt of I. This is your equivalent inductance, and since the voltage across L1 and L2 are same, okay, so it means that which will be equal to L1 di1 upon dt plus is equal to L2 di2 upon dt. Okay, so it means that di upon dt will be equal to, so di by dt will be equal to V upon L equivalent. Similarly, di1 upon dt will be equal to V upon L1, and di2 upon dt will be equal to V upon L2. Okay, so substituting the value of the differential of I1 and I2 in this particular equation, we are getting, okay, so we are getting 1 upon L equivalent, okay, is equal to 1 upon L1 plus 1 upon L2. Okay, so I hope it is clear. So it is similar to the parallel combination of resistors. Okay, so for n inductors connected in parallel, so connected in, you can say parallel So total inductance will be equal to, so total inductance will be equal to 1 upon L equivalent is equal to 1 upon L1 plus 1 upon L2 plus so on plus 1 by Ln. So I hope it is clear how we are approaching this particular expression. So that's all for today, guys. I will see you in the next tutorial. Please do subscribe to the channel. Thank you.